So let's look at how we can manipulate logarithms. So we can call these the laws of logarithms. So we've got 3 here in this page. So if we have log to the base a of two numbers multiplied together, x times y, that's the same as log to the base a of x plus log to the base a of y. So let's see why that is the case. Just put some numbers in. So let's say we had log to the base 2 of 4 times 8. So 4 times 8 is 32. So the answer to this is, what number do we have to raise 2 by to get the value 32? Well, the answer there would be a value of 5. So we can see here that this here, log to the base 2 of 4, which is the first one, plus log to the base 2 of 8, well, that's going to be, what number do we have to raise 2 by to get 4? The answer is 2. What number do we have to raise 2 by to get 8? The answer is 3. So that's 2 plus 3, which is 5. So this does actually work. So we've got log to the base 2 of 32, which is 5, which is the same as log to the base 2 of 4 plus log to the base 2 of 8. Now if we weren't in logarithmic terms and we were just in normal numbers, we would equivalently be saying 2 to the power of 2 times 2 to the power of 3 is equal to 4 times 8, which is 32. So let's look at the second example here. Log to the base a of x upon y is equal to log to the base a of x minus log to the base a of y. So let's put some numbers in here and see if we can get this equality. So log to the base 2 of 32 upon 8, well, according to what we have above, that should be the same as log to the base 2 of 32 minus log to the base 2 of 8. Well, log to the base 2 of 32 upon 8 is log to the base 2 of 4, which will give us a final value of 2. But we know that log to the base 2 of 32 is going to be a value of 5, so we have to raise 2 to the power of 5 is 32, and we have to say that 2 to the power of 3 would be 8, so that would be equivalent to 5 minus 3, which is equal to our value of 2, so it does work. So in terms of powers, we would have 2 to the power of 5 upon 2 to the power of 3, that's the same as 2 to the power of 5 minus 3 is 2 to the power of 2, which is a value of 4. So this is the equivalent exponential form of this logarithmic form here. So finally we look at number 3. Log to the base a of x to the power of n is the same as n times log to the base a of x. So let's put some numbers in. If we say log to the base 2 of, say, 4 to the power of 3, well, according to what we have above, that should be the same as saying 3 times log to the base 2 of 4. But we can rewrite this thing here as log to the base 2 of 4 to the power of 3, which is 64. So that's going to be equal to 3 times log to the base 2 of 4, so log to the base 2 of 4 is equal to 2. So that's 3 times 2 is equal to 6. And that's right, because log to the base 2 of 64 is 6. We have to raise 2 to the power of 6 to get a value of 64. Now again, if we write that in terms of exponentials, that's equivalent to saying 4 to the power of 3 is equal to 2 to the power of 2 all to the power of 3, which is equal to 2 to the power of 2 times 3, which is 2 to the power of 6. So take your time and read through these and see if you can maybe put in different values for yourself. I would keep it to the power of 2 just to keep it simple, but you can put in different values and then see that you can actually work out, and you can get the left hand side equal the right hand side for each of these. And don't worry too much if you're not following all of that, because again it's best done by example, and we'll get over a few of these examples in the next video.